All right, we're going to talk about oxidation states of sulfur next. The end of chapter 10 has to do with thiols. So all things sulfur related at the end of chapter 10. And we're supposed to redraw the structure with all valence electrons of sulfur showing. So it doesn't say anything about the carbon. So we can make that an R for every example. R, 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 S, 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 S. I'll do the easy one. H, lone pair, lone pair. There you go. That's a thiol, right? Hey, isn't that the answer to C? That's a thiol. Oh, that's the wrong one, by the way. Number two. Maybe it's the right one. I don't know. Number one. Yeah, number two. Oh. Okay, 1, 2. Got it. 1, 2. I don't think I have any more twos. Okay. Let's go increasing number of O's. SOH. No surprises here. And notice I'm not putting lone pairs on the oxygen because it didn't ask for that. Valence electrons on sulfur. And that there, you got to know your alphabet for the other three. You notice they all end with some version of Nic acid. Alphabetical by number of oxygen. E-I-O. Alphabetical, E-I-O. Next one's the sulfenic acid. This one here. Sulfinic acid. We didn't know that. We do now. And then the E is followed by I in the alphabet. Vowels we're talking here, right? Sulfinic acid has a double bond to O and a single bond to OH. And sulfur has one lone pair. Oh, I got carried away with my lone pairs, so that's okay. And then sulfonic acids have as many O's as possible. And we've seen sulfonic acids already. We saw toluene sulfonic acid all semester, starting with test 2. And it has 2 double bonds to O. I guess the trend continues on the lone pairs. There you go. And just a reminder, that's the only one you need a pKa. And apparently, we also know this one. And we don't have to worry about pKas here. It doesn't mean they don't have pKas. You're just not responsible for them, okay? That wasn't asked for on this quiz at all. And good old oxidation state review. Now that you got all the electrons around the sulfur, here's your quick review for oxidation state. Every bond has an oxidation state. If you have a bond to a more electronegative atom, you get a +1 oxidation state. If you have a bond to a less electronegative atom, you get a -1 oxidation state. The bond to carbon gives a 0 oxidation state because F and C and I all have the same 2.5 electronegativity, CSI, remember? Back on TV, I hear. All right. So sulfur here has 1, 2, 3, 4, 5 bonds to O, each one +1. We're looking at +5 here. Next one over, it has a bond to a less electronegative H. Oh, -1. CSI. She asked, what about the bond to carbon? C, S, and I all have the same electronegativity, giving an oxidation state of 0. So I won't even talk about that bond. Bond to a more electronegative O, just one of them, +1. And 3 bonds to more electronegative O, and the last one, plus 3. I think we're on track for 4 activities in an hour because that's it. Yeah, there you go.